2.
All right. Well, if you left us, I am back now doing the you do, but I did do a problem in between. So if you left us, you will see the problem in between before you see this. So how did you do this? And I said, I want to find dy dx. I need another pen. This pen is heading for the happy hunting ground. So, dy dx. Okay, so that's the derivative of x third y to the fourth plus the derivative of y to the seventh minus the derivative of 3x to the fifth plus the derivative of 10, and that equals 0. All right, so once again, there's a product rule. X third, do a derivative with respect to x of y to the fourth plus y to the fourth, derivative with respect to x of x third. That takes care of this. Now we have to take care of this, which is the derivative with respect to x of y to the seventh minus the derivative with respect to x of 3x to the fifth, and the derivative of the constant is 0. So let's do all these now. Here, I cannot take the derivative with respect to x of y, so I have to use my chain rule. So I do d dy. That means now I can take the derivative with respect to y fourth with respect to y, but I have to tack on my dy dx. Otherwise, it's not right. Here is simply xx. This is going to be plus 3x squared y to the fourth. Here I cannot take the derivative of y to the seventh with respect to x, so I set up a derivative with respect to what the function is, and I tack on a dy dx, and this is simply 15x to the fourth. Now what I want to do is bring everything that is not a dy dx over. So I'm going to bring this over to the other side, and I'm going to bring this over to the other side. So what I'm left here is going to be x third. The derivative of y to the fourth is 5y. dy dx. This goes over to the other side, plus the derivative with respect to that is plus 7y to the sixth dy dx. This goes over to the other side. So it's 15x fourth minus 3x squared y squared. Now I want to solve for dy dx, so I'm going to factor it out. I'm going to write this as 5y x to the third plus 7y to the sixth equals 15x fourth minus 3 x squared y squared. Divide out by this sucker here. And we get a final answer.
That's a y, I think.
That's a y. Sometimes I don't complete my y's. And then they look like x's. Well, this is 15x fourth minus 3 x squared y squared divided by 5y x to the third plus 7y to the 6th. And that is your answer. Once again, your answer is in terms of x and y because the function was in terms of x and y. Now, if you can do this problem, you can do any implicit differentiation problem, which is not exponent or log, which is on the next test or on the final. So this is a good example. If you don't understand how to do it, keep going over it, keep going over the video, and learn how to do things like this, where you have a product rule and a couple of other things added on. The most complex we're going to get. Okay, and now we're going to go into some practical problems involving, well, not yet, because we have to do another one. We have to do one involving an exponential. All right, the last final, when they never had it before, they did have an implicit differentiation with an exponential in it. Most of us never taught it. I actually did, but I didn't spend a lot of time on it. So let's take another example, and we're going to get y e to the x minus y equals 3. We want to find dy dx. Well, let me ask you something. Do I really need implicit differentiation here?
No, Dr. Mirabile, we can divide by y.
All right. What you can do is actually, you actually have two methods. I can actually factor out the y and solve now I would take dy dx using what? Well, most of you would probably use the quotient rule because you don't like the chain rule. I'm going to pull a fast one on you here, though. I'm going to do this as a chain rule. Notice this is to the power 1. If I bring it up into the numerator as we do, we negate the power. That means I don't have to do the quotient rule. So what is dy dx? Okay, so what is dy dx? That's what I want. So what I want to do is let my u equal e to the x plus 1. Okay, because we're doing the chain rule. Those who can do this in your head now realize that the answer is minus 3 e to the x plus 1 e to the x. But those who still don't know how to do it in your head, don't worry about it. All right, so we got to do du dx. And what's the derivative of e to the x? Well, remember I solved it. It came out counterintuitive. E to the x, right? What's my chain rule formula? Well, what's my chain rule? Not the formula. That's what I use for implicit. So my chain rule I gave is what? dy dx is a n x to the n minus 1 du dx. All right, what's a here? A is 3, n is minus 1, right? And I have u, and so let's substitute it in here. Is going to be minus 1 times 3, And it's going to be u. This is u. I'm sorry, no, not x. This is u. U to the n minus 1. So it's going to be u to the minus 1 minus 1. And du dx is what? E to the x. Now let me get rid of this bottom part so it doesn't confuse you. That's the trouble with having just one board. Okay, let's get rid of this. This is what we had before. Okay, so this is minus 3 u to the minus 2 e to the x. Or minus 3, u is e to the x plus 1. Minus 2 e to the x. Or minus 3 e to the x over e to the x plus 1 squared. Is that e to the x plus 1? Oh, it's minus 1. My fault. I just thought, well, let's make that a plus here, so it's going to be good for everything. Okay, so let's make this the problem with a plus. Since I made that mistake down here and I carried it through, let's put the plus in it at the beginning. So this is your answer for dy dx. Now, if you want to, you can take this function and use the quotient rule and see if you get the same answer. Notice I use the chain rule. So if you want to use the quotient rule, I'll just set it up for you. I'm not going to solve it, but you do get the same answer. The quotient rule, if you don't like the chain rule, of course you're going to want to use the quotient rule. So you're going to have y equals 3 over e to the x plus 1, and dy dx is going to be, this is going to be u, is going to be v times the derivative of u, which is 3. That's 0, minus 3 times the derivative of ex plus 1 over ex plus 1 squared. When you do this, you will find out you will get the same answer, minus 3 e to the x over e to the x plus 1 squared. You can try it. If you like doing the quotient rule, have a good time. All right, but you will get the same answer. Now, if you like to use the quotient rule, fine. If you don't, that's all right. So, now we're going to go into some applications of implicit differentiation. Now, the applications of implicit differentiation, basically, we're going to go into two applications. One is going to be the elasticity of demand, and the other one is going to be how to calculate the tax receipts. Pretend you're an IRS agent and you calculate the tax receipts for Dr. Mirabile. Okay, Dr. Mirabile stays out of jail by sending in his tax returns, or stays out of all the penalty functions. How much time?
Slightly less than a minute.
All right, so we have less than a minute. This is the last one. So this is the end of our Friday class. You do have a quiz that I gave you in the last class. And everybody, please, remember these videos are a week ahead. So submission or anything that, if it changes from what I said a week ahead, we will send you an email. Okay? All right, everybody have a nice weekend. Stay healthy. And I'll see you next Monday.